Okay, so I'm going to go through some single motor and motor bank calculations. I might do it all in one shot here. We'll see how it goes. But there is other information in your module that I'm not going to cover here, so definitely still continue to read through your module and answer the objective exercise questions to make sure you get everything they're talking about. So we just want to talk about some things or some terms here in the difference between overload and overcurrent. So overload we kind of think of as I've plugged too many things into a circuit, or I've asked a motor to do a little bit more than its required rating, and I'm going to draw more current for a certain period of time. That's eventually going to trip the motor under overload. Short circuit protection would be like a line-to-line short, and the current for that gets extremely high very quickly. So we have overload protection and overcurrent protection. Okay, so just for the difference. So every motor that we're going to have overload and overcurrent protection. Motor overloads are sized to us for a specific rule. We'll go through that, and then the short circuit protection is a fuse or a breaker ahead in the line. When we size this overcurrent protection, though, it's going to be increased due to the starting characteristics of these motors. They have extremely high current on startup, so we have to oversize the fuse or the breaker. By default, we're going to be using a non-time delay fuse if it's not listed. It should be listed, but if it's not, use non-time delay. The reason it's non-time delay is that's the short circuit protection, because we have overload protection down here. Okay, so this can see that inrush of current for a brief period and not trip, and then it's going to allow the motor to work accordingly, and then if it gets overloaded, these guys will trip. Okay, so we got to have both. So in this question, it's just a single motor, continuous duty. We're going to start at the bottom and work our way up. So Rule 28.106 is talking about the conductors for a single motor, so insulated conductors. It says subrule 1 says that for continuous duty shall have an ampacity not less than 125% of the full load current rating on the motor. So we go to take our FLA 60 amps times 125%, and we get the 75 amps here, and we go to table 2 and size the conductor, and we're sizing based on 75 degree. Don't have that written. When I do it on the board, I would write 75 degree termination temperature. So then we're going to table 2, excuse me, under the 75 degree column, and we're going to pick a wire based on that. So we need number 4s being fed down to this motor. Then we size our overload protection, which gets us to 28,306, and that's specifically for the overload protection for the motor, and it basically says that whether fixed or adjusted under subrule 1A, we're going to do 125% of the full load current rating of a motor having a marked service factor of 1.15 or greater, and 115% excuse me, if it's less than 1.15 or not marked, because if it's not marked, we're going to say it has a service factor of 1. So because we're at 1.15 and Rule 28.306 tells us to use 125%, so these overloads either have to be purchased or set at 75 amps. Then we go to the overcurrent, and we go to 8200, which is telling us to go to number subrule 3 says the rating of overcurrent device required by subrule 1, which is telling you what we need, is going to not exceed the values given in table 29 using the rated full load current of the motor. Okay, so we're going to go to table 29 and see exactly what we're going to size this overcurrent with. So table 29 has a list of different types of motors. It starts with alternating current, single phase all types, squirrel cage, and synchronous. And under those it says full voltage resistor reactor starting. Full voltage just means basically no reduction in starting current. And then we have auto transformer start delta starting, so those are reduced voltage, wound rotor, and direct current. So in this case we are a 3-phase motor, so we'd be a squirrel cage, full voltage, and we go to non-time delay, and it's at 300%. Okay, so if you go to table 29, I'm going under full voltage resistor reactor starting, across to time delay fuse, and getting 300%. So again, we take our 60 amps FLA, times that by 300%, and then we go to table 13 to pick a available overcurrent, and you can see that we went down to a 175. And the reason we did that is because in Rule 3A says that the rating of the overcurrent device required shall not exceed the values given in table 29 using the rated full load current of the motor. Okay, so that's telling us we need to go down. If we have this calculation of 180 amps right here, we can't exceed that. That's a table 29 calculation, so we have to go down when we go to table 13. So we'd have 175 amp fuse, 75 amp overloads, and number 4 is going to this motor. Now in this example, the big difference here is we're non-continuous. So it's giving us a duty rating and for how long it's going to be on. It's 208, 3-phase, 25 FLA, and a service factor of 1.1. So we're going to do it just the same. We start at the bottom, work our way up, go to our conductor size. Now we're going to have to go back to Rule 28106 because we're not continuous. So we have to go to sub-rule 2. And it says the insulated conductors of a branch circuit supplying a motor for use of non-continuous duty shall have an ampacity not less than the current value obtained by multiplying the full load current rating by the applicable percentage given in table 27 for the duty involved. So if we go to table 27, we're looking at intermittent duty and 5-minute rating. So intermittent duty and 5-minute rating is giving us a percentage of nameplate current rating of 85%. So we take our value from table 27, 85%, times it by the FLA, and we get our current of 21.25. Then we go to table 2, and we can use a number 12 for that. Then we go to 28306. Now we're in B because we're less than that 1.15, so we're using 115% as the multiplier for our overloads. And this is the value that the overloads need to be set or purchased at. We don't round up, we don't go to another table. Whatever that calculated value is exactly what we're looking for. So 28.75. Then we go to 28200, and we don't see any reduced starting or anything like that. So we are going under full voltage start, non-time delay fuse, and we're using that 300%. So we get our calculated value from table 29, and again, that's a maximum. So when we go to table 13, we go down to a 70 amp fuse. Okay, so big difference here. We just went to table 27 because it's non-continuous. Okay. Now this example here just gets us into another table where we're continuous now, but they've given us a horsepower rating instead of an FLA. So 28010 is telling us which table to go to if we have using horsepower instead, and it's telling us to go to table 44 or 45 as applicable. So we go to table 44, 45, and we'll see what the difference is between them. So table 44 is 3-phase AC motors, and it's got horsepower rating and then the type of motor we have based on the voltage. And table 45 is 4 single-phase motors. So in this question, we have a 3-phase, 460 volt, 20 horsepower motor. So I go to table 44, and I'm looking at 460 volt, and I scroll down to the 20 horsepower, and I should be at 27 amps FLA from table 44. Okay, so you might have to use that table if they give you a horsepower. Then again, we're continuous, so we're 125% of that rating, and we can go to table 2 again under the 75-degree column because that's what the termination temperature is for these questions, and we are able to pick a number 10 under the 75-degree. That's good for 35 amps. We don't have an we don't have a service factor marked on this, so we're going to say it's a service factor of 1 or unmarked, which gets us into the 115% from 28306. So again, the number that you get is what we would put if I asked you for what is the overload set at. That's what they would be at, 31.05 amps. Go to overcurrent protection. This time we got to watch out because this is a breaker. Okay, so if we go to table 29, we have to look over all the way to the far right hand column now. Instead of under non-time delay fuse, we're under maximum setting inverse time circuit breaker. So we're under, now we're using the 250% instead of 300%. So we take that 250 times our 27 amps, our FLA, we get our 67.5, again calculated value, so we go down to a 60 amp on table 13. Okay, now we have a wound rotor motor. It's got its own little specific scenario here. So we got a 30 horsepower, 460 volt, 3-phase continuous duty motor, and so that's for this guy. Now this motor has a 70 amp secondary current for the light intermittent starting duty resistor bank. So this draws 70 amps. This draw that we're going to go from the motor up here is based on this 30 horsepower. So we're going to have to go to table 44 to find out what the FLA is. And then we have our service factor written here too. So again, we're going to start at the bottom, do the motor first. So we get our table 44 value, which is 40 amps FLA, 125% because it's continuous. We get 50 amps from table 2, we can use a number 8. Then we go to overload protection is 125% of the FLA because we're at 1.15. Then for our fuse, we were going to go to table 29 and we have to look under wound rotor. Now this is again a very specific type of motor. Talked about it in third year. But he's got a total different column under table 29. So he's 150% regardless of time delay, non-time delay, or circuit breaker. So it happens to be a non-time delay fuse. So we're going to use 150% and we'll get 60 amps, and then we can go to table 13 and actually leave that rate at 60. So now for the secondary part, what we're going to do is go to rule 28, 112, 1A, and this is going to tell us how to deal with these secondary conductors. So it's 28, 112, secondary insulated conductors. Subrule 1 says insulated conductors connecting the secondaries of wound rotor motors to their controllers. So that's this wire right here from the wound rotor motor to the controller of 125% of the rated full load secondary current for motors used on continuous duty, or the percentage of rated full load current specified in table 27 for motors used on non-continuous. So this guy's continuous, so we can just go with the 125%. So we take 125% again of that 70 amps, that's the current of the secondary controller. We get our 87.5 based on our calculation. We go to table 2 and we got to pull number 3s to the controller. Now the second part of 28.112, subrule 2 says ampacities of insulated conductors connecting the secondary resistors to their controllers shall not be less than that determined by applying the appropriate percentage in table 28 to the maximum current that the device are required to carry. So from the resistors to the controller is this wire right here. Okay, so now we're going to go to table 28. Based on the resistor duty classification, so it says light intermittent starting duty. Again, that's not the motor, that's the resistor bank. Okay, so it's a continuous motor, but this is for the resistor duty classification. So we go to light intermittent starting duty, and we see a percentage of 65% under table 28. So we take our 65% times 70, again the current for the secondary conductors. We get 45.5 amps, and we pull number 8s, which are good for 50, to the resistor bank. Okay, so treat the motor part exactly like you have been. It's a continuous duty. Things couldn't be different. Aside from the fact from table 29, because it's a wound rotor, we're going to have the whole thing with the wound rotor is we have reduced starting, so we don't need to set the overcurrent at such a high value. Okay, and then it's the resistor bank of when we add it in to the starting, so we kind of let it get up to speed, and then we add add resistors in at the beginning so that we can help reduce the starting current. Okay, so then we have to size the conductors for that resistor bank as well too. Okay, again, a specific motor. And another specific motor that we'll talk about are the Hermetic refrigerant motor compressor. So it's got its own set of rules, so that's 28700. And 28700 is, you can see under the headline, it says refrigerant motor compressors. And this whole section here is about these motors specifically. Okay, so you'll see these in AC units and rooftop units. It says to check 28010 under special terminology and locked rotor current. So we're going to use that value coming up here potentially. So under definition under 28010 says locked current rating, a current rating marked on the electrical equipment where not marked deemed to be equal to 6 times the full load current rating of the nameplate of the equipment or the rating from table 44 or 45. Okay, so 6 times the current is going to be our locked rotor current. And think of locked rotor as basically the motor wants to start, something preventing the rotor from turning, so we're going to see an extreme amount of current there until that rotor starts to spin. But again, we're going to size our conductor, get our overload protection, and our overcurrent protection still just the same. So we got a 10 horse, 230 volt, 3-phase motor. Got to go to table 44 and get that FLA, apparently FLC to full load current. Okay, either way, same thing. Get our FLA, and now we're going to go to a specific rule for hermetic motors, not go back to the general rules for continuous or non-continuous. So 28704, saying horsepower rated equipment, that's telling us to go to table 44, 45 to do that. Again, it says that where the full load current rating is not marked, the equivalent full load shall be found from table 44 or 45. Subrule 1 there is telling us there to say also 6 times the full load current rating for locked rotor current value. So our locked rotor current would be equal to 6 times of the 28 amps. So we get 168 amps. Okay, and we'll see where that becomes applicable here coming up. So 28706 is talking about our conductor ampacity. It says the allowable ampacity of the insulated conductors or branch circuits supplying a motor compressor or equipment consisting of one or more motor compressors and other loads shall be based on the marked rated current of the motor compressor or equipment and shall comply with the general requirements of the section. So basically that just tells us to go back to 28, but we're only doing this because that's what the rule told us to do, is to go back to 28106 and for the continuous duty and use 125% of that of the 28 amps to get 35 amps. Then we go to table 2 under the 75 degree and pick a number 10, which is good for 35 amps. Then we go to 28710. So this is a bit different here than us normally going about the service factor. And 28710 talks about overload protection specifically for refrigerant motor compressors. It says the branch circuit insulated conductors and control equipment for each motor compressor shall be provided with overload protection complying with the rules 28302 to 28306, except that the rating or setting of an overload relay shall not exceed 140% of the mark rated load current of the motor compressor, and the rating or setting of other overload devices such as fuses shall not exceed 125% of the mark rated load current of the motor compressor. Okay, so what are we going to actually use for this then, because it's again a hermetic, is we're using that 140% of the marked rated current. So this is what our overload protection will be, again, purchased or set at. So a little bit different than the motors we're talking about, have been talking about, but again, specific for hermetic motors. So then we go to overcurrent for hermetic, and it's 28708. It says except as permitted in subrule 2, each ungrounded conductor of a branch circuit feeding a motor compressor shall be protected by an overcurrent device rated or set at not more than 50% of the locked rotor current of the motor compressor, unless such a device will not permit the motor from starting, in which case the rating shall be permitted to be increased to 65%. Okay, so we're going to take 50% of our locked rotor current, which is 168 based on that 6 times, And that's what we're going to use to go to table 13. So we don't go to table 29 for hermetic refrigerant motor compressors. Okay, but it says that right in the rule. That's exactly what we're going to do, is take 50% of the locked rotor. So I sized it from table 13. Again, can't be more than that. So I go to an 8 amp fuse. If this gave me nuisance tripping, I would be allowed to change this to 65% and then size it again. Okay, that's what the rest of that rule said. Okay, so some special things for hermetic refrigerant motors. Just make sure you're following the rules in the right section and it's not too terrible. Okay, so I'm going to stop there and we'll talk about motor banks next.